Alright, so for our second to last class period, we're going to talk about encryption, and then finally for our last class that we do, we'll actually go through the VPN stuff and get everyone ready for the hands-on final lab, final whatever you want to call it, because it's more so just another lab and not like a final exam. So don't like freak out over that because it's called a final. It's just the last lab that we're going to do. Is how we're going to call that. So yeah, today is encryption. So keeping all of our data self-contained. And for the record, this is actually a homegrown picture where I stuffed all the dogs in a kennel. No, it was more so like actually only the lab is mine. The other two are Scott Paulson, IT guys, network administrators. And all the dogs were in one area, and when my dog is like tired, he's like, I'm just gonna go now. And he went and hopped in his box, and the other dogs were like, well, what are you doing in there? So they all scurried over, so I closed the door on them. So they got a lot of togetherness inside of there. Except for the chubby corgi was not having it. So you could see him pressed against the thing. He maybe didn't go in so voluntarily. But anyway, so the idea behind encryption, and I'm guessing this isn't anything super radical, but we want to take some sort of data and make it look as random as possible. Our official term would be pseudo-random is how it appears. So we shouldn't be able to discern any sort of pattern coming out of the data once it's encrypted. Why is that a big deal? If we discern patterns.
I know somebody to explain that used like MD5 or SHA, something like that, to encrypt the Tux penguin image, and it just looks like a slightly junkier version of the image because you can still see.
Sure. So you don't want to be able to derive. Yeah. In the end, we don't want to be able to derive the original data from it, right? So when we think about, let's talk about WEP. What's WEP? I'll specifically talk about it in this class. There's a place where you can configure WEP. Where is that place at? Wi-Fi. Yeah. So WEP is that one you want to use or don't want to use? You don't want to use WEP at all. Do we know why? Yeah, so the problem with WEP is that WEP actually uses your password as the encryption key for all traffic being sent around. And then what it does is has like so there's your password for part of it. And have you ever looked at a WEP key? It's all hex because the actual setup for WEP couldn't handle like, normal letters and numbers. So you're literally seeding the key directly into the algorithm, basically. And then that part never changes. You're not changing your password constantly as you're going along. So then the other part of the key for WEP is what's called an initialization vector, and it's about 40 bits, give or take, or 40 bytes. No, 40 bits. So if we're talking about doing wireless stuff, and we have this 40 bits of randomness that we're generating, is 40 bits a lot of data? No. Is 40 bits a lot of data when we tag it on with like roughly 60-something bits of a key? It's like the key never changes and then these 40 bits of randomness are tagged on to the end. Does that pose a problem? So with Wi-Fi, when you're doing WEP encryption, after about 5,000 packets, give or take, the key will repeat itself that we use to encrypt data. So the key that should be rotating all the time repeats itself, and then we no longer talk about random, because then we can actually start to notice patterns inside of the data. So as soon as you can notice a pattern inside of encrypted data, if you're really good at math, what can you do? Yeah, you can decrypt it. You can decrypt the data without really needing the key. Or in the case of WEP, what it lets you do, once you figure out the pattern and you know how the algorithm really works, you can actually derive the key from all this data. Any idea what it takes to actually derive the key? Like for computing power, once you have about 5,000 packets? No. Like a netbook is perfectly comfortable doing it in less than a minute kind of deal. So that's where there's encryption, because that is technically encrypted, but that's not always the way to go. So one of the actual problems we come up with in encryption is the false sense of security that people can get. So we can say, well, my Wi-Fi is protected, right? But if someone chose a bad algorithm, it is protected, but it takes no effort to break it. So it's kind of like there's the whole discussion of like usability versus security kind of things. So how many of you use Signal? You know what Signal is. Okay, some of you know what Signal is. Signal is encrypted voice and text messaging. It's like a third-party service that encrypts all of it. So exchanges a key that it's a not a key escrow either. So it's like if you and I call each other and we're friends on Signal, the key or the call is point-to-point encrypted. So that's great from a technical perspective, but there's key management problems, like as in if I get a different phone, you're going to get prompted to accept my new encryption key. Also, if someone's man-in-the-middling the call, you're going to get prompted to accept my new encryption key. That's maybe great for me, or us, because I can say, hey, did you get a new phone? And you'd be like, oh yeah, that's why you got that message. If I was trying to do this like with my mom, when she gets the prompt and doesn't understand what's going on, just accepts and says yes, and then could be getting deliberately man-in-the-middle, but still feels secure because she's using the secure application. So that's where, like, when we go down the road of talking about encryption, it's actually like, it's a good thing, generally speaking, but it can be dangerous too because it lulls people into this false sense of security if they do it wrong. And there's a lot of places where it's done wrong. So we'll talk about the algorithms, what we have, and there's two different main types of encryption. Either way, what they're doing is taking plain text, is what's the official term for the unencrypted data, and then whatever algorithm we use, and then once it's encrypted, it's called ciphertext that we kick out. So this also has a unique discussion from a historical context. So how many of you knew or know of the history of encryption, at least in the United States? You do? Yeah? So what happened with encryption? What was the deal?
Couldn't use the really fancy stuff because the government said no.
Yeah. So the government, and actually you could use good encryption in the US. That is the one thing you could do that, but you couldn't leave the country with good encryption.